One of the strangest facts in the solar system is hiding in plain sight on Venus. One spin of the planet takes longer than one trip around the Sun. Venus orbits the Sun in about 225 Earth days, but it turns once on its axis in about 243 Earth days. That means its rotation is slower than its year. If Earth behaved like that, a birthday could arrive before the planet had finished a single turn beneath your feet. There is another twist. Venus rotates in the opposite direction to most planets. On Earth, the Sun appears to rise in the east and set in the west. On Venus, because of its backward spin, the pattern would be reversed, though the thick clouds would hide the Sun from the surface. This is not a guess. Spacecraft radar has measured Venus's surface through its clouds, letting scientists track how the planet turns. The basic fact is well established. The deeper story is less certain. Why did Venus end up spinning so slowly and in the wrong direction? Scientists think several processes may have mattered. A major impact early in its history could have changed its spin. Gravitational tugs from the Sun may have slowed it over time. Venus's massive atmosphere may also exchange momentum with the solid planet, acting almost like a brake and a push at different times. The exact balance is still debated. What makes this so fascinating is that Venus is nearly Earth's size, made of rock and lives in the same inner solar system. Yet its clock is completely alien. The takeaway is simple. Planets are not just balls moving around the Sun. They are worlds with histories, scars, atmospheres and rhythms of their own. Venus reminds us that even our nearest planetary neighbours can turn to a beat we barely expected. The reason Venus can have a longer spin than year begins with a simple idea: orbiting and rotating are different kinds of motion. A planet's year is its path around the Sun. A planet's day in this sense is how long it takes to turn once on its axis. These two clocks are related by gravity, but they are not locked together for every world. Earth happens to spin quickly compared with its orbit. Venus does not. When the planet's formed material in the young solar system was already swirling as dust and rock gathered into larger bodies, each growing planet inherited some spin. But that first spin was not guaranteed to last. The early solar system was crowded, rough and changing. Worlds collided. Gravity pulled from every direction. Atmospheres formed, escaped, or thickened. For Venus, scientists are especially interested in three possible influences. First, a large collision may have tipped or slowed the planet long ago. Second, the Sun's gravity raises tides in Venus, not ocean tides like Earth's, but flexing in the solid planet and its atmosphere. Over vast time, those tides can change rotation. Third, Venus' dense atmosphere moves with powerful winds, and that moving air can trade a little angular momentum with the ground beneath it. None of this means scientists have one neat answer. The measurements tell us Venus spins slowly and backward. The models explore how it may have reached that state. Different histories can sometimes lead to similar results, which is why the question remains active. The important lesson is that a planet's rotation is a memory of forces acting across billions of years. It is like a record with scratches from impacts, tides, atmospheres, and time. Venus did not simply choose a strange day. Its strange day may be the result of an entire planetary life story. And that turns a simple fact into a clue. If Venus teaches us anything, it is that planets are not built from one cosmic template. It is tempting to imagine a planet as a simple object, round orbiting, spinning, predictable. But the solar system is full of worlds that break that picture. Venus spins backward and slowly. Mercury is caught in a special rhythm, with the Sun turning 3 times. For every 2 orbits, Uranus is tipped so far over that it almost rolls around the Sun. Jupiter and Saturn spin so quickly that their days are less than half of Earth's. These differences matter because rotation shapes a world's experience. It affects sunrise and sunset, the movement of atmospheres, the strength of weather patterns, and sometimes the way heat is spread around a planet. Rotation does not decide everything. Distance from the sun, atmosphere size, chemistry, and magnetic fields also matter. But spin is one of the great hidden ingredients in planetary identity. This is why Venus is useful beyond its own story. When scientists study worlds around other stars, they often know very little at first. Maybe a planet-sized mass orbit or the starlight passing through its atmosphere. Its actual day may be unknown. Some close-in exoplanets may be tidally locked with one side often facing their star. Others may rotate in ways we have not measured yet. The solar system gives scientists a library of possibilities, not a final rulebook. The known fact is that planets can have wildly different spins. The uncertainty is how common each type is across the galaxy. That uncertainty is not a weakness. It is the doorway to discovery. A single fact about Venus quietly changes the question. We stop asking whether a distant planet is Earth like in one simple way. We start asking what kind of world its entire history has made. And somewhere beyond our sun, another planet may be keeping time in a way we have not yet imagined.